Hi everyone, welcome to Camoholics, your one-stop channel for chemistry to make it simple, easy and exam ready. Today I bring you a very interesting question from complexometric question related to EDTA. So here is the question that I'm going to solve in today's video, and it's really a very interesting question. So let's solve this problem. So here what they are asking is, let's first read the question. Okay, calculate the concentration of a solution that was prepared by mixing 50 ml of 0.03 molar nickel ion with 50 ml of 0.05 molar EDTA solution. The mixture was buffered to a pH of 3. Given the formation constant of nickel EDTA complex is 4.2 into 10 to the power 8, and alpha 4 for this complex at pH is this. Now this is going to be a completely new question, very interesting question. So here, before solving this question, I want to explain some points regarding this. So what happened, this is the structure of EDTA. I hope everyone know that. Nickel, nitrogen, COOH and COOH. So this is a hexadentate ligand, right? And it can create a maximum of -4 charge from by removing this proton and proton. Okay, but this is a question from conditional formation constant. Here they have given is formation constant, but and also mentioned the pH, and they also mentioned this alpha 4. Now what is the meaning? Actually this is a question from conditional formation constant. Why I am saying this as a conditional formation constant? Okay, let's say when EDTA form a complex with this M+2 ion. Okay, so what will happen is EDTA has 4, let's write it as minus y minus 4. It was written it like that. Okay, so if we write the equilibrium constant for this, you are going to write it like plus y minus 4, and at equilibrium it is going to form a complex like this. -2, right? But and in this case you will write the formation constant Kf. This is the Kf, and Kf is going to be like m y minus 2 divided by m plus 2 and y minus 4. And for this, the normal formation constant is already given here, which is 4.2 into 10 to the power 18. But in real solution, okay, when we talk about a real solution, whether it is going to form y minus 4 or not, it depends on pH. It depends on pH. Okay, so based on pH it can form multiple type of ion like X6Y plus 2 or X5 Oh, sorry, let me write it again. H6y plus 2. It can also form H5y plus 1 or Hy without any deprotonation, or it may be like H3y negative or H2y negative or Hy minus 3 or y minus 4. So these are the conditions that it can form different types of anions based on pH. Okay, so here what is given here, the pH is 3, which is acidic, and when acidic pH is there, we can say that it may be possible that it is, let's assume that it is not going to form, the concentration of this concentration of y minus 4 is going to be less. Okay, so in this case, now that comes the term this alpha 4. Here it is written on the subscript, actually it is like this. Okay, now here comes the term alpha 4. This is nothing but the fraction of concentration of y minus 4 to the total EDTA concentration. Okay, and it is also given to us in the question. Actually this is minus 2.51 into 10 to the power minus 11. Okay, so this is the value. Now this is the formation constant by assuming that it is converting into completely dissociating into y minus 4, and however only this amount is going to be converting into the y minus 4. This is the concentration actually. So now the new conditional formation constant is going to be like, let's say K dash is equals to Kf multiplied by alpha 4. This is the new formula based on your conditional formation constant, and if you multiply this 4.2 multiplied by 10 to the power 18 multiplied by 2.51 into 10 to the power minus 11. Okay, if you are going to multiply this, what will you find? You will found this 1.0 into 10 to the power 8. So this is going to be your answer. Okay, now actually so up to this I think you understand what is the conditional fraction constant. But what we need to find, calculate the concentration of they are asking for nickel plus 2 ion. Concentration of nickel plus 2 ion means the free nickel plus 2 ion after, because here obviously small amount of complex is going to be formed, and we need to calculate how much amount of nickel is left after once the complex is formed. Now what we need to do is, so let's see, here we have already given that nickel plus 2 is 50 ml. Okay, and its concentration is 0.03 molar plus EDTA, and it's also 50 ml, and its concentration is 0.05 molar, so total volume is going to be 100. Now obviously the concentration has changed, so we need to calculate the new concentration. So concentration of nickel plus 2 nu multiplied by volume nu is going to be equals to concentration of nickel plus 2 old and volume old. Old concentration is 0.03 multiplied by old volume is 50 and new volume is 100, right? and we need to calculate this new value. So I'm going to write it like this: nu divided by 100, and if you solve this, it's going to give you 0.015 molar. Okay, similarly you can calculate the value for new concentration of EDTA as well. Concentration of EDTA, new volume nu is equals to concentration of EDTA old volume old. This is 0.05 multiplied by 50 divided by, again because total solution is again 100, so new concentration of EDTA is going to be like 2 is 0.025 molar, right? This is the new concentration. Now let's say the amount of complex, this is the complex NiY, its amount is X, then free anion, amount of free anions, this is X, so Ni plus 2 free is going to be like 0.015 minus X, because if we are going to this is the total concentration of nickel. If we subtract this from this, we will find the value of this nickel, free nickel anions. Similarly for EDTA, free is going to be like 0.025 minus X. So this is the new concentration. And if we think of a new conditional formation constant, this is the formula for, this is the symbol for new conditional formation constant, and if we put the value of concentration of complex divided by concentration of nickel ion, 0.015 minus X, and concentration of EDTA 0.025 minus X, this is going to give you the same value that we are getting from here. Okay, this is going to give you the same value, 1.05 into 10 to the power 8. Now if you solve this quadratic equation, you will find X is going to be 0.014999986. So this is the value of X. Don't round off it, because if you are going to round off it, it is going to give you what? 15, and when you subtract it from this value, you are going to get 0, but here the value is not 0, so put the value as it is. So now the free anion nickel plus 2 free, concentration of free anion is going to be 0.015 minus 0.0149996, and if you solve this, you will find it like 1.4 into 10 to the power minus 8 molar. So this is the concentration of nickel anion in the solution when it was after forming the complex with the EDTA. So that's what they are asking. So let me repeat again. Actually, whenever you find the EDTA and any metal ion, first think of that this question is related with the complexometric titration. Then if there is any condition, like most basically they will give the condition of pH, because what kind of anion is going to be formed, it depends on the pH. So if these two things are there, you must certain that this question is not from the direct formation constant. This question is going to be from conditional formation constant. Okay, so first we need to treat it as a normal formation constant, find the value of Kf. So, and the value of Kf is already given over here. Okay, but because this is the real situation and if condition is changing, it may be possible that only a small fraction of EDTA is converting to y minus 4. So we need to calculate the fraction of that molecule, and which is represented as alpha 4, and it is also given to you in the question. Because we already calculated the fraction, and for conditional formation constant, this is the formula where you need to multiply this fractional constant multiply by actual formation constant, and you will found the value of this K. Then what we did, we calculate the new concentration of nickel ion as well as the concentration of EDTA ion, and then we apply the same. Obviously, in formation constant, the formula is not going to be changed if we are calculating directly from the anions that are present in the solution. Okay, so this is the formula. Put the new values here, calculate the value of x, and once you calculate the value of x, whether they are asking for you to free nickel anion, or they can also ask you the free EDTA concentration, you can calculate that value by subtracting the value of x from either any one of the equation. So that's how you need to solve this conditional constant. So with that, I will close this video here, and I would like to thank you for watching this video. And if you find this video helpful and you get some knowledge from this video, please do like and comment what you want to learn more from me, and please don't forget to hit the subscribe button so that you can get updated for the new videos, and please do share with your friends so they can also be get benefited. Okay, thank you, bye bye, see you in my next video.